Now let's head on to axioms of probability. Axioms are something which are basically a starting point, which means ki, when we define the probability, then these are the first three principles on which the probability has been defined. Okay, so there is no proof of these principles like that, which means this is just a starting point. And based on this starting point, we will be proving anything else. Whatever else we will be having, we can prove that based on these starting points. Okay. Okay, let's just see these axioms. So axioms means just a starting point. Probability has to be non-zero, which means the probability, the probability actually has to be between 0 and 1. And if you take the probability of all sample space, then the probability is 1, which means it is saying that, like, let's suppose in the sample space there are different outcomes. Maybe let's suppose this is S1, maybe S2, S3. Then S1, S2, S3 has to be mutually exclusive, that you know, right? So either S1 will occur, or S2 will occur, or S3 will occur, which means the probability that this set will occur, probability of this set, I will tell you the formula later, but the probability of this event, if I just call this as a particular event, is basically either S1 will occur if every of this element of this event is disjoint, then you can say either S1 will occur, probability of S2, and probability of S3. So either this will occur, this will occur, this will occur. So basically finally this probability is 1. This is how it is defined. The probability, all of the outcomes probability combinedly can be at max 1, which means that 1 is the highest number and that is distributed among all of these numbers. Now let's suppose that S1 is having higher probability. So suppose this is S1, this is S2, or maybe let me take a familiar example. Suppose you are rolling a dice, then the possible outcomes could be 5, 6. Now maybe the dice is unfair and 1 is having this much probability, and 2 is having maybe higher probability, 3 is having maybe even higher probability, and 4 is having, let's suppose, lesser probability, 5 is having, let's suppose, higher probability, 6 is having, let's suppose, highest probability, like that. Okay, so anything can happen, but ultimately all of these probability sums, probability of all of these will be just 1, which means these numbers sum up to 1. Maybe it is 0.1, maybe it is 0.2, maybe it is 0.3, maybe it is 0. I don't know, maybe 0.05, and like that. Like you can just come up with some numbers, so that the probability is basically 0.45 maybe. Okay, or let's suppose these two are 0.05. I think this sum is 1. I'm not sure, but should be 1. नहीं, ये sum तो 1 नहीं है. ठीक है, let's not worry about it. Okay, let's not worry about it. So you can have some numbers here such that the total summation is 1. So basically the probability mass, this is like, I will tell you about the probability mass in the discrete variables, but this is called probability mass, which means the mass could be different. That here at 1 I am having lesser mass of the probability, but at 6 I am having the higher mass of the probability. But ultimately all the probabilities should be 1. Okay, so probability of all of these outcomes should be 1. And the third rule is saying that if A and B are disjoint, so A and B are what? Can anyone tell me what is A and B? A and B are events. Okay, everything should be an event. This A is an event. Whatever I'm writing inside the probability has to be an event. This A is an event. The sample space itself is an event, because if you recall that event is a subset of the sample space. So here, see, here these are the possible events, and this one of the event is sample space itself, right? In power set, that set automatically comes, right? So sample space is also an event. That's not a problem, and probability of that event is 1. Okay. So whatever I'm writing inside this has to be an event. So this is an event, which means the event which is having A union B. Okay, A is an event, B is an event, and A union B is also an event. The probability of A union B is probability of A plus probability of B if A and B are disjoint. So this is the third rule, which is additivity rule, and we cannot prove it. It is just taken to be granted, because that's where the probability gets started. So I hope you are getting the things. Now suppose that if someone asks me that what is the probability of maybe head will occur or tail will occur. So basically I will say that this is probability of head plus probability of tail. Reason being is that, why I can write like this, reason being is that this is one event, and this or means union. Okay, or means union. So basically they are asking probability of head union tail, which means this is probability of head plus probability of tail. Reason being is that this head and tail are disjoint. Why they are disjoint? Because I know that these are just a part of my sample space, and in sample space everything is disjoint. This is head, this is tail, and this is sample space. In sample space everything is disjoint. And also, like, you know, by the common sense that you cannot have head and tail simultaneously. There is nothing common in head and tail, because these are just elements of the sample space, and that's why they are disjoint. So suppose in general, if the sample space is having S1, S2, S3, S4, Sn, then can you tell me what is the probability of S1, S2? I'm just writing like this, S3, like this. Okay, Sn, this will be probability of S1 plus probability of S2 plus probability of S3. Why? Reason being is that everything is disjoint. If everything is disjoint, I can use plus symbol. And why these are disjoint? Because these are my elements of sample space. This is elements of the sample space, and elements of sample space are having two properties. Can anyone recall me two properties? Disjoint, and any other property that we have? Yeah, mutually exclusive, which means this is set of all possible outcomes. Set of all possible outcomes. There cannot be any other outcome than this. Okay, this is set of all possible outcomes. There cannot be any other outcome than this, and this is disjoint. Yes, mutually exclusive and exhaustive. That's what we call. Okay, let's just extend my third property to a set of disjoint events. If you are having disjoint events, maybe number of events could be infinity. Let's not worry about it. So if the number of events are infinity, then also I have probability of A1 plus probability of A2 like this. Okay, I do not care whether the number of events are finite or infinite. If there are infinite events also, and if they're disjoint is the only condition. If they're disjoint, you can have the plus symbol in between. Okay, but here I do not want to actually tell you, but I don't know. I can just reveal this here. Here it should be countable infinite, which means it cannot be uncountable infinite. Infinite also have two types. If you have if you have done with your discrete mathematics, then you must have knowing that in infinite are either they are countable infinite or uncountable infinite. In the discrete, you have studied this, or you are going to study this in TOC? I think in discrete, right? After TOC. Okay. ठीक है, कोई problem नहीं है. Basically, infinite are two types. There was a mathematician and who has discovered that infinite is not just infinite. Infinite could also be two types. One is called countable infinite. Another one is called uncountable infinite. You will study this later. Okay. So countable infinite is basically discrete sets. I will not obviously talk about this now. You will study this, and you will be I will not even talk about the definitions. Okay. Dhruv, you will be studying this countable and uncountable later. But here I just want to make you a point that these set of events should be can be infinite, but should be countable set only. Okay. Reason being is that, let me just tell you that if you move to the continuous probability, let's suppose that you say that there is a number line, and in this number line, this is 0 to 1. Like, you define a probability that maybe a uniform probability or any probability that 0, let's suppose a probability that A to B can occur is maybe 1 upon B minus A or something like that. Okay, which means let's say the probability that you are throwing a dart in this, or maybe you can say that you are picking a random number, and the random number that you are picking that will be in this range. Maybe you can say 0.0 to 0.5. It is having 1/2 probability or something like that. Okay, so basically, let's suppose like you define something like this, and you try to add all the probabilities. Maybe I don't know, like I can tell you here or maybe later. So we will talk about this later. But if you maybe try to add all of these probabilities, then you might be knowing that in the real case, the point probabilities are 0. Like probability of 0.2 is basically 0. Why it is 0? I will tell about this also later. So basically, if you just add on all these probabilities, then you will say that probability of, maybe, let me just say that it is probability of union of all the events. Let's suppose you are having all the events which are I equal to 1 to infinity. There are infinity events, and then you can say it is summation of all the events, and then, which means here you are having E1 union E2, and then you are converting that to a summation, and then you can say that since individual probability is 0, then it should be 0, which is not true, because this is the adjustive sample space, and it is actually the probability 1, and it cannot be 0. So the only thing that is going wrong in this equation is from here to here. You cannot go for every infinity. You cannot go from here to here. If this infinity is uncountable, you cannot go. Anyway, I think we do not have any context about the countable. We do not have any context about the real numbers and continuous probability and these things. So I will talk about these things later. Don't worry. Okay. But here I just want to make you sure that number of events here has to be countable. It cannot be uncountable. And I think for the gate purpose, it is also not needed. But okay, no problem. Okay. Now axioms are clear. At least these 3 axioms are clear, that probability is non-zero, probability is adjustive, like probability is 1, sample space probability is 1, and if the events are disjoint, then there will be a plus symbol in between. Okay. Okay. Now let all the outcomes are equally likely, which means, let's suppose in your sample space you are having S1, S2, S3 till Sn. These are all the outcomes, and I'm saying that all the outcomes are equally likely, which means what? Probability of S1. Actually, I am having a loose notations. Otherwise, I should be writing like this. See, I should be writing everything in the set format. Like this is the probability of this set S1 equal to probability of this set S2, like this. I mean, I should be writing like this, but I will not be writing, which means I will be just omitting this curly braces. Okay, I will be just writing probability of S1. Otherwise, I mean, books also do this, and they just specify this in one line, that from now on we are not going to write probability of S1 like this, because it is just too much of writing. Okay, so just to have a easier convention, we are just going to write probability of S1. Otherwise, it is an event, and I should be writing it in the set format. But it is called abusive notation. I mean, you are just taking the leverage of not writing the proper notation. That is called abusive notations. That is very much allowed. Okay, in many places these abusive notations are allowed, which means instead of writing like this, I will be just writing like this. Okay. So probability of S1 is equal to probability of S2. If every event is equal, if every outcome is equally likely, I will say that everything, and finally this is dot 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 probability of Sn. This is equal to, if everything is equally likely, if there are n events, then n outcomes, then it is just 1 by n. If everything is equally likely. Okay. Now why it is 1 by n? Like, okay, let me just prove it maybe. ठीक है, ये समझ में आ गया, ये everything is equally likely, so this should be equal. Now can anyone prove it that it should be 1 by n also? Just tell me that if everything is equally likely, then this is okay, but it should also be equal to 1 by n. Can anyone prove this using the axioms of probability? It is easy, right? You will say probability of S1. I mean, I should be writing basically union or something. S2, S3. You know that this probability till Sn, this probability is nothing but, since all are disjoint, you can this probability is 1 because this is a sample space using the axioms, using second axiom, and then you can rewrite this as probability of S1 plus probability of S2 plus probability of S3 or probability of Sn, and then this is also equal to 1. And then from here to here, can you tell me that which axiom I have used? Can anyone tell me quickly which axioms I have used? Third one, right? Yes, disjoint wala, third one. So I have used the third one, and then since I know that everything is equally likely, this is given to me. This is given to me. If everything is equally likely, I can say that probability of any S1 equal to 1 upon n. Okay? I mean, har jagah I will be writing probability of S1, probability of S1 like this. So I can easily prove that it is just 1 upon n. Okay? I hope that is fine to everyone. So basically, if every outcome is equally likely, it is just 1 upon n. I mean, that is also basic sense. Now, if you want to find a probability an event out of such experiment where everything is equally likely, and if you want to find a probability of an event, then event will be, let's suppose A is an event. It could be, let's suppose, S1, S2, maybe till Sk, something like this. Okay, maybe it could be anything. Let me just define an event like this. Can you tell me the probability of this event? Probability of A. Can you calculate the probability of A, where A is your S1, S2, S3, like this. I mean, anything can occur till K maybe. Then you will say that this A is a combination of these two, these all, then this is just probability of S1 plus probability of S2 till probability of Sk. Is this okay to everyone? Why I can write from here to here? Because these are disjoint, because these are the part of sample space and everything is disjoint in the sample space. So that's why we can write like this. Now tell me, what is this probability of S1? 1 by n, because it is given to me. 1 by n, because it is given to me. Okay? This is 1 by n again. This is because this is given to me. So this is k by n. Finally, you got k by n. What is k here? K is number of elements in this set. Number of elements in it. Number of elements in it. N is total elements. Right? So if everything is equally likely, then you can say probability of that event is nothing but total elements in that event and upon total number of sample points. In general, you cannot say this. Like, to hold this formula, you should be having one condition. What is that condition? What is that condition? Condition is that everything is equally likely. Okay? To hold this formula, you should be having one condition, that everything is equally likely. If everything is not equally likely, which means, let's suppose S1 is having some probability, which is, let's suppose, 1 by 3, it is having 1 by 4 like this, then you cannot say, you can just count the number of elements in it, because the distribution is not same. Okay, so it will be just, let's suppose that let's suppose everything is not equally likely. Let's suppose that I have S1, S2, S3, S4, S5, maybe S6, something like this. Okay, and then let's suppose then the probability of this is maybe 1 by 6, maybe this is 1 by 6, maybe this is 2 by 6. Okay, let's suppose this is 1 by 12. Okay, this is, I don't know, maybe 1 by 6. ये remaining कितना बचा? Can anyone tell me quickly? It should be written as, this is okay, 1 by 3 is remaining. 1 by 3, 1, ठीक है, 3 by 6, 5 by 6 plus 1 by 12. 1 by 3 is remaining. I hope that is correct. So let's say that this is the probability distribution that I have. Now tell me, what is the probability of S1, S2, S3? Is this 3 by 6? Is this 1 by 2? Should I just tell the number of elements here and upon the total number of elements? No, right? It cannot be like this. So what is the probability of S1, S2, S3? You need to combine these three probabilities. So probability of S1, S2, S3 is not 1 by 2. It should be 1 by 6 plus 1 by 6 plus 2 by 6, which is 4 by 6, which is 2 by 3, not 1 by 2. Okay? That is wrong. Which means you cannot just count the number of elements here, number of elements in A. That is wrong. If the distribution is not equal, the number of elements in A upon the total number of elements will not work. That is the only shortcut for the case when distribution is equal. Okay? So distribution means like the probability of every outcome should be same. Okay? So just to make yourself very familiar, the distribution and probability mass. Can I say that probability mass is equal? Yes, because this is called mass. Like mass is distributed equally. Okay? Probability mass is distributed equally on every point. Or I can say probability distribution is equal, maybe. I don't know. Probability mass is actually better term. That probability mass has been distributed equally. Okay? Okay, let's see this. If two dice are rolled, two dice are rolled, two dice are rolled, what is the probability that sum of the upturned faces will be equal to 7? For the two dices, your sum should be 7. Okay? So what are the possible outcomes? What are the sample space? If you're rolling two dice, then it could be 1, 1, could be 2, 2, like this, right? could be 1 1 1 2 1 3 1 4 1 5 1 6 2 2 1 2 2, like this, right? It could be 36, I think. 36 outcomes are possible, and for sum to be 7 and everything is equally likely. Now just tell me, in this event the sum is 7, there should be an event such that the sum is 7. In this event, how many possible outcomes are there? Maybe you will say some 6 outcomes, maybe 2 5 5 2 4 3. Okay, 2 5 5 2, maybe 3 4 4 3 and 5 and then 6 1 and 1 6, right? 6 1 1 6. So 1 2 3 4 5 6. Yeah, 6 possible events are there. Everything is equally likely. So number of elements here, which are 6, upon total elements, which are 36, then 1 by 6 is the answer. 6 is number of elements in A. This is A, and then probability of A will be this. This is number of elements in A upon total elements. Okay. So the notation I'm using is basically probability of A is number of elements in A upon total elements. That is applicable when every outcome is equally likely. Okay. So 1 by 6 is the correct answer. Now let's see some principle out of these probabilities, and then we will be solving some questions. So you might be thinking that these are very basics and you might be bored, or you might be thinking that these are tough. I don't know, depends on the student, but everything will be normalized. I mean, if you are thinking that this level is too high or too low, like after a point, you will be seeing that, okay, now you understood the basics and now you are able to solve much question, and you are able to understand the probability very much clearly. So that's why we need to build the basics. So these are just axioms and some principles that we are building. So the inclusion-exclusion principle says that probability of E union F. Can anyone tell me what is E union F? It is an event. Everything has to be an event. If E is an event, F is an event, then E union F has to be an event. That says that it is equal to probability of E plus probability of F minus probability of E intersection F. So let's just prove this formula. Probability of E union F is equal to probability of E plus probability of F minus probability of E intersection F. That's what my inclusion-exclusion principle says. Can you prove this? So everything like we need to prove in this probability using just a set theory. So let me show you how. See, let's suppose this is my sample space where all possible outcomes occur. And now you are having event E, you are having event F. So this is event E, this is event F. Because these are the sets, right? Everything is set. So that's why we will be just using the Venn diagram to prove any such of these things. We will be just using the Venn diagram. If in the question I will just say you that, okay, whether verify which of the following is true. Okay, I may give you anything like this, which of the following is true. Then you just need to use the Venn diagram. Because these are just sets and we can use the Venn diagram and the disjoint property. Let me show you how. Tell me what is this this particular thing in the Venn diagram. This is E intersection F, right? If I'm not wrong, this is E intersection F. This is E intersection F complement. You know? And this is F intersection E complement. Okay. Now this E union F, tell me, are these three events, if I just talk about these three events, are these three events, if I just say that these are the three events, then are these three events are disjoint, which is E intersection F complement and E intersection F and F intersection F E complement. So we just need to find the events which are disjoint. Now just write this in the disjoint, this format. Okay. Yeah, so let's just call this as A. Let me call this as B. Let me call this as C. I mean, instead of writing this whole thing, let me just write ABC. So this is A union B union C. Okay. I mean, instead of I can write these things, but it will just take more of the space. So I'm writing A union B union C. Now tell me, can I write it PA plus PB plus PC? I can write. Can anyone tell me why I am able to write like this? Because these are disjoint events. Yes, Samir. Yes, Arnab, that is correct. So because these are disjoint events, and because of the axiom 3, yes, Devanjan, these are disjoint, and because of the axiom 3, I am able to write like this. So LHS is coming like this. Now let's see if RHS is also in the same format. So LHS I got like this. ठीक है. RHS में ये probability of E को क्या लिख सकते हैं? E union this A union B ना? This can be written as A union B. ठीक है? Is this okay to everyone? This E is A union B. This F is, I think, B union C. Okay. This E intersection F is just B. Okay. So the first term will be PA plus PB because these are disjoint. This is the first term, and the second term will be plus. This is the second term PF. PF will be PB plus PC, and the third term will be minus of PB. This is your RHS. Just check whether LHS, RHS both are same. PA, PB plus PC, right? So LHS is PA plus PB plus PC. RHS is also PA plus PB plus PC. So basically both are same. That's why I can say that this E union F is probability of E plus probability of F minus probability of E intersection F. So whether like whatever we have in our hand, we can prove it using just the axioms that we have and using the set theory. So we will be using the Venn diagram to prove any such of these things. Okay. Okay. So this is proved using Venn diagram only. Now you can extend this, and you can extend for 3 also. If you have studied this formula for 3, like I mean, you might have studied that this E union F union G in the set theory is nothing but E probably like, what is that formula? Can anyone tell me? E union F union G is, or maybe for the 2 only, this is plus, or what we have in the set theory. How do we represent it? If I want to say E union F, then how do we represent this in the set theory? I think in the set theory we have number of elements in the E union F like this. We have n of E union F, right? Okay. We have generally n. Okay. Okay. Here we are having the P. That's okay. So like you can have the inclusion exclusion formula for the 3 or for the 4. For the 3, like we will be saying that first we will be doing plus plus plus, and then minus of 2 to 2, and then plus of 3. Okay. So this is how we can have inclusion exclusion for 3. So I know you must be knowing the proof that you are basically subtracting this 3 intersection 2 times. That's why you just have to add this one more time like this. You must have got the proof in the discrete. Okay. So this was our inclusion exclusion formula. Now let's move to the De Morgan rule. Now tell me, is this set, which is E intersection F complement, is this set, and this set, which is E complement union F complement, are these 2 sets are same? In the set theory, you must have studied this, that these 2 sets are same, which means E union F complement, like E intersection F complement. Let me just check it. See, this is E, this is F. Now E intersection F, this is E intersection F. E intersection F complement means everything apart from this, which means everything apart from this. Okay. This is E intersection F complement. Isn't it same as E complement union F complement, which means E complement will be your this. Yeah, E complement union F complement will be having this. If you take the union of these 2 sets, which means E complement will be this and F complement, then you will be basically not including this, and you will be including the exact set, which is this. So anyway, these 2 sets are same, that you must have you must be knowing from the discrete mathematics. So if these two sets are same, then the probability of these two sets are also same. It is just a simplification of the sets. I have not used any probability axioms, or I have not used any probability formula to prove it. If these two sets are same, then these two must be having the same probability. Okay, I just simplified it. So there is no proof that is required from the probability side. You just need to know from the discrete mathematics side. Like if these two sets are equal, then the probability of these two sets are also equal. Similarly, if these two sets are equal, then the probability of these two sets are also equal. Okay? These are just a discrete mathematics things. If you do not know, then don't worry about it. For now, you can remember it, or you can try to visualize it, or later you can see the discrete mathematics lecture, and then you will be getting it. Don't worry, we will not be having much of the discrete mathematics in the probability. I'm just telling you one or two formulas. Otherwise, we will be just dealing with the probability only most of the time. You don't need discrete mathematics for the probability. Okay, if you have not seen the discrete lectures, it is perfectly fine. So E intersection F is 1 minus probability of E intersection F complement, because E plus E complement is just 1. So either this event will occur or its complement will occur. So which means probability of E plus probability of E complement is 1. So that's why you can have probability of E intersection F is equal to 1 minus probability of E intersection F complement. Reason being is that these two summation is 1. Okay, probability of any event A plus probability of A complement is just 1. Now from here, can you just simplify this? This is just 1 minus, this is probability of E intersection F complement is E complement union F complement. Okay. Similarly, you can have one more formula. I mean, you do not need to remember it. Just for the sake of practice, I am just telling you. 1 minus probability of E union F complement, sorry, E intersection F complement, union F complement, and then 1 minus probability of E complement intersection F complement. Okay, you can have these formulas if you want. I mean, these are very basic formula, and you can easily derive these formulas. Okay. Okay. Now let's solve some questions. Here they are saying that probability that it will rain today is 0.5, and probability that it will rain tomorrow is 0.6. So probability that it will rain today is 0.5, and probability that it will rain tomorrow is 0.6. The probability that it will rain either today or tomorrow. If this is either or, then what you need to do? Either intersection or union. Tell me. Union, right? In case of or, you will be having a union. Today, union tomorrow. The probability is 0.7. Then they are asking probability that it will rain today and tomorrow, which means they are asking probability today and tomorrow. So how to solve this? They have given something in union and they are asking something in intersection. Yeah. Okay. They have given something in union. They are asking something. Should I be using this formula? I think this formula won't work. Reason being is that you do not have this intersection probability. I mean, you have the intersection probability, but not this one. So what should I be using? Should I use any sort of this formula? Okay, let's just check it. Samir is saying that you can find it using this formula, that probability of today union tomorrow will be probability of today plus probability of tomorrow, inclusion exclusion, right? Minus probability of intersection. Okay, and they have asked this intersection thing. And what is this formula? This formula is inclusion exclusion. Yes, Karthik, that is right. So this is inclusion exclusion. So here this is 0.7, which is equal to 0.5 plus 0.6 minus x. X is what you want to find out. This is 0.11 and 0.11 and 0.7. 0.4 should be the answer. D should be the answer. So how to calculate this? You can just use the inclusion-exclusion principle. Okay, which says that probability of A union B, if they ask, let's suppose they have given some in union and they are asking about the intersection, then you can use the inclusion-exclusion, or vice versa, which means they are asking intersection given the union, or asking union or given the intersection, like this also. Okay, let's solve this question. Here they are saying that A intersection B is given, A complement B complement is given, and then A union B is been asked. Can you solve this? So earlier also the same story, but earlier instead of A complement they have given A, instead of B complement they have given B, but they have given complement here. So I think we can solve it. First we need to find the general probability of A, which is 2 by 3, probability of B, which is also 2 by 3, and then I can solve this. So probability of A union B is probability of A, which is 2 by 3, plus probability of B minus probability of A intersection B. This is 4 by 3 minus 1 by 2. So it will be 8 minus 3 by 6, which is 5 by 6. 8 minus 3 by 6. 4 by 3 minus 1 by 2. This is 2 by 3. 2 by 3 minus 1 by 2. 2 by 3 minus 1 by 2. 5 by 6, no? Okay. So they have given 10 by 12. Okay. So we are getting D. So everyone is getting B as an answer. I got it. So B is your answer, right? So it is very simple question where you just need to use the inclusion-exclusion principle again. And you know why it is works. I mean, you do not need to prove it again and again, but you know it. That using the Venn diagram, if required, you can prove it.